Okay, I'm going to do proportions. First, I'm going to do a problem from 6.3, which is fractions. So we're definitely looking at a division problem because we're looking at a how many. So really, what we're doing is we want to find 35.5 yards divided by 3/8 yards per towel to see how many towels we can make. So I'm going to change that to 71 halves divided by 3/8. By now we know that we multiply by the reciprocal. We know we can cancel some. So I have 284 over 3. So my problem now becomes 3 divided into 284. Let's see if I do 90, that's 270. 14, I know I can get 4 more. I got that remainder of 2. So I know I can make 94 towels. Now it asks us how much material is left over. And be very careful if you say it's 2/3. Meaning this 2 divided by that 3. Because if you said 2/3 yards, well, that's greater than 3/8. You could make another towel. So go back to what we were really dividing. If I wrote this way, we were dividing 3/8 into our 71 halves. So when I got down to this remainder of 2, it's 2 of these. So we have 2/3 of the 3/8 left. So our remainder is definitely 2/3, but it's 2/3 of the 3/8, which is 2/8 is 1/4 yard of material. You just have to be careful that you go back to the original divisor and dividend to make sense of your remainder. Okay, same kind of problem. This is a division problem, but I'm going to do it with proportional reasoning because that's what our section is. So I am going to do a thing called scaling up, which is one way to reason with proportions. So I know that every book, so one book will use up 1 1/4 inches of the shelf. So I'm going to scale up. 2 books then is double this. That would be 2 1/2. Okay, I can scale up again. I'm going to double the 2 because doubling 2 1/2 gives me 5 inches. So for every 4 books, I use up 5 inches. Well, now I can make a big leap because I can scale up now to 35 inches multiplying by 7. Multiply by 7 here. Suddenly I have 28 books for 35 inches. That gives me 2 1/2 inches left. But what do I know about that? 2 1/2 inches gives me 2 books. So 28 plus 2 is 30 books will fit on my shelf. So that's using one method of proportions, which is scaling up. And I'll do that again later. Okay, we're going to learn about ratios. Not so much constant of proportionality and scaling, because I realize we're running out of time in this semester. And there's a lot just with proportions. So here's the thing about ratios. They compare quantities, so there's usually units. So I just made some corn tortillas last night, and I found out that the ratio of my masa to water was 4:3. So if I did 1 cup of masa, that's not a less than, that's a C. Well, I used 4 1/4 cups. That means I used 3 for the water. Yeah, and they turned out pretty good too. But notice units are important. I wrote them in there. So when I do a problem like this, where we're going to learn about part to part, part to whole, here I've got number of males to females. So I know my numerator is males, denominator is females. And let's see if it's at the end, there are 7 males to 12 females. That's my ratio. If I look at the game room, which I'll do here, still males to females, but in the game room had 14 males, 24 females. These are called part to part because if you go back to the problem, if I combine males and females, they form the entire whole, add all my parts. I get the whole, which in this case would be people that are in the rooms. So the next problem is a part the whole problem. Males in the game room to number of people in the game room. Males is the part, wholes to people. See, game room, I got 14 males. 14 plus 24 gives me the people. That's my relationship of my part, males to my whole, the people. So in a lot of these problems, you got to figure out, is it a part to part or a part to whole? Okay, proportions. Notice it's an equation. So you probably grew up solving stuff like x over 5 is equal to, I don't know, 8 over 7. And you probably did some cross multiplying and stuff. I'm hoping to teach you that you only have to do that, because that leaves you with just x on the left hand side, 5 times 8 divided by 7. In this case, x is 47ths. You did not have to do that, meaning you did not have to do 7x is 5 times 8 is 40, because you end up dividing by the 7 again, and it's already done there. So here's a proportion. 3 cars to 8 students. Notice I put my units in there because now with my proportion, I need cars over students I'm looking for how many. That's my unknown. And I know I have 1,200 students. I want to solve for X. I'm multiplying over there to just leave me X over here. 3 times 1,200 is 3,600 over 8. And that's like 450 or something. It is 450. We would need 450 cars. So again, a proportion is an equation. I did this with scaling up with the books. I kept the relationship the same so that the ratio of books to shelf space stayed the same. When I doubled one, I doubled the other. Okay, I'm going to do this 2 ways. First, I'm going to scale up, meaning I want to match right here. I have 12 tickets for $15, and here I have 20 tickets for $23. I'm going to scale up and I just did the worst rookie mistake. I'm going to change my ratio because I don't like this. The reason I don't like this, and I'm glad I actually did it, it was because we're used to seeing dollars per item. So I'm going to flip these ratios. Wish I could say I did that on purpose. $15 for 12 tickets. And over here, it's $23 for 20 tickets. Well, what I'm going to do is I'm going to scale up. Basically, I'm going to find the LCM of 12 and 20, which happens to be 60. That way, I can look at the numerator, how much it cost me for 60 tickets, and with the same denominator, I'll be able to make a decision. So to get to 60, I had to multiply 12 by 5. So that's 60 tickets. So I got to do the 15 by 5, $75 for 60 tickets. Over here, I multiply by 3. I get $69 per 60 tickets. Same number of tickets, less money. That's my better buy. So that's using scaling up. Next thing I'm going to do is what they do in grocery stores. I'm going to do unit price. Nope, didn't do another slide there. Or unit rate is a better word, because it's not always price. What's going on here? I thought I was erasing it. Come on. Okay, now I'm going to use unit rate. Meaning I'm taking my $15 per 12 tickets. I'm going to divide 15 by 12 and give me the price per single ticket. That's $1.25 per ticket. Do the same thing here. I've got $23 for 20 tickets. divide 23 by 20. I've got $1.15 per ticket. Again, same amount of tickets, less money, better buy. It's called a unit rate because we made our denominator 1. In this case, 1 ticket. When you get to the store and you go shopping, if you want to compare cereal, you may see one thing priced at, I think they do ounces and cents. So you may see like 49 cents per ounce versus 43 cents per ounce. And by law, they're supposed to do this. So you got a unit rate so you can easily see the better buy. I'm not going to do scale drawings so much. You've seen them, and since you can go through this, but what I will show you is a lot of times on map, you have a legend. And on your map, it'll be like this. Maybe like 30 miles, and it'll be like 1 inch. So you can take 2 points on your map, kind of measure it. If this was 2 inches, you know it's 60 miles away because you just scaled up using your legend, or notice this is a ratio of 30 miles per 1 inch. So that's basically overview of proportions. We'll do more in class.